unmultiplying, right? Remember the first half of the unit was all about multiplying. Now we're taking things and we're unmultiplying them, so we're turning it into multiplication questions. We're going to do a couple of these, see if we can't notice a trend. We're just going to remind ourselves how to multiply. And when you multiply, they did the first one for you. You do your first term, so you distribute, you get x squared. Then you do your second term, you get 4x, and 2, 10x, 8. And you end up with these 4 terms when you multiply out 2 binomials. Your 2 inside terms can combine. It becomes 6x. You'll notice when you multiply these 2 binomials together, we ended up with a trinomial. Awesome. If you check the next couple of examples, we're going to notice that this is a trend that keeps happening. So as I multiply these 2 things together, this question right here, x times x would become x squared. X times 3 would become plus 3x. 3 times x becomes plus 3x. And 3 times 3 becomes plus 9. So just like the example they did for us above, you'll notice that the 2 middle terms are the same, right? You have a 3x and a 3x. That means you can combine them. If they're like terms. They combine to become 6x, where everything else stays the same. There's x squared plus 6x plus 9. That would be your end result when you multiply those 2 binomials together. Fantastic. Let's try a couple more. So we have x plus 1 times x plus 7. If we multiply those 2 things together, we go x times x is x squared. X times 7 is plus 7x. 1 times x is plus 1x, which we just did plus x. And then 1 times 7 is plus 7. Again, you notice the exact same trend, right? The first term, x squared, the 2 middle terms you can combine together, right? 7x plus x is equal to 8x. And the last term is 7. We can do a few more of these. I think it's a little redundant. I think it's it's the same trend over and over and over again. The trend that you're going to notice is that there's a few trends in this. When you're multiplying 2 binomials together, you're going to get a trinomial. Okay, that's a 3-term polynomial. That means if we were to unmultiply a 3-term polynomial, what should we end up with? 2 binomials, right? We should be able to go the other direction. We should be able to take a trinomial, turn it into 2 binomials. My awful joke is that in life, there's 3 guarantees, right? Have you heard that? Like death, taxes, and when you factor a trinomial, you get 2 binomials. Right? Those are the 3 guarantees. It's like the best joke I got all year, so if you didn't like that one, it's not getting better. Every single time, it's going to go this way. Like 95% of the time. It's not actually guaranteed. My bad. You'll also notice a couple other trends. Big trend I like to notice is that your first term, this guy, is always coming from these 2 terms multiplied together. So you're going to notice that like your x squared in the front is constantly coming from those x's multiplied together at the front. The middle terms and the last term are a little trickier to figure out. Right? Like they're going to be hard, but this is a very obvious trend for us. Right? It's constantly becoming. And we're going to try to use that knowledge to help us factor or unmultiply trinomials. We're going to scroll down a little bit. Under here, factoring by inspection. We're going to keep going. Here, that's example 5. The only reason why, like that stuff above, is just a different method. It's a build-up for a different method on how to factor. I use something different. Okay, so this is a factoring problem. It says factor the following trinomials where possible. We have x squared plus 8x plus 12. All right, we know that when we factor this trinomial, we're going to end up with 2 binomials, right? That's what we just proved to ourselves. We also know We also know that when we factor and we get those two binomials, that the first terms create the first term. Right? So if we look at this x squared comes from these two things multiplied together. The two things that would multiply to be x squared would be x and x, right? And it almost always works out that way. So this is going to be x, this is going to be x. It's the next terms that are tricky, okay? Figuring out what these binomials should be. And the first terms follow that nice trend. The other ones, not so much. So we need a strategy. The strategy that they use above is called inspection. It's kind of like guessing and checking. We're going to use a method called diamond method. It's very similar. Anybody in that math NC prep like, yeah, okay, good. Diamond method is like the way to go. So to use diamond method, you draw a diamond. Very complex, right? Diamond. Not enough room to do diamond method on this page. On the top of the diamond, we're going to draw two diamonds here. On the top of the diamond is your A value times your C value. All right, so the people are like, what's A and C, right? These are coefficients from your trinomial. So when you look at a trinomial, it's going to be in this form. Ax squared plus bx plus c. That's a c, not a 0. That's the form trinomials are going to fit. So for this question, c would be 12. A would equal 1. Right? There's an invisible 1 there. So on the top of the diamond, we put A times C. In our case, 12 times 1 equals 12. So the top of the diamond is 12. On the bottom of your diamond, you put your B value. For us, in this question, our B value is 8. Right, so that's the setup for your diamond. The top is A times C, the bottom is B. The sides, you got to figure out. Right, so you're trying to figure out two numbers that would multiply to be the top number and add to be the bottom number. So if we're looking to multiply to be 12, add to be 8. Anybody think of two numbers that would multiply to 12 and add to be 8? 6 and 2. Those are the sides of your diamond. 6 and 2. Diamond method's really just a way to organize inspection, which is what's going on above. Right? And it's not factoring. Diamond method is not factoring. It's organizing the information for you and it's picking numbers. Factoring is what we're doing over here, which is taking this trinomial, breaking it into two binomials multiplied together. We got the first terms, right? We knew it was x and x became x squared. That's better here. The second terms are the sides of the diamond. So when you did your diamond method, you got plus 6 and you got plus 2. If you were to multiply these two binomials together, you would get that triangle. Usually like the first 2, maybe 3 times you do diamond method, it's like, whoa, and then it starts to really roll. And you're like, oh, okay, I get this. And people really like it. Okay, so let's try another example. We have this trinomial right here, x squared plus 13x plus 12. We know when we factor, we're going to get two binomials. We know that the first terms of those binomials create the first term of our trinomial. So we can kind of look at that and say, well, we need it to be x squared. That means the first terms must have been x and x. because those multiplied together would create x squared. The side numbers, so the second term in each binomial, comes from your diamond method. You draw a diamond. On the top of your diamond is your a value times your c value. A is the number in front of x squared. C is the number that's last. In our case, 1 times 12. That's A times C. On the bottom of your diamond is your B value. In this case, 13. The sides of the diamond are up to you to pick. So you're looking for two numbers which would multiply to be 12 and add to be 13. If you're ever stuck and you're like, I can't think of it, focus on the multiplication. Alright, so for instance, there's a very limited thing that can multiply to be 12. 1 and 12. 2 and 6. 3 and 4. Those are the only things that multiply to be 12. So those are my only options for the side of my diamond. Now you need to ask yourself, which one of these pairs adds to be 13? 1 and 12. Okay, so if you're ever stuck and you can't get it, make that chart to help.
Does it matter which side we put, like the 1 and 12 on?
Nope, so you could flip it and it'd be fine. So if you put 12 and 1, it's the exact same. Yeah. Awesome. The reason we did that diamond method was the sides of the diamond, 1 and 12, become the sides of your binomials. This thing factors to be x plus 1 times x plus 12. We unmultiply that trinomial. Alright? We're going to try another one. And then you're going to try 3 on your own. So, this guy. We got x squared minus 13x plus 12. We're looking for two binomials when we factor it. The first one comes from right here. It'll be x and x. Okay, because those two things would create x squared, the first term. Then we need to get the sides of the diamond. The sides of the diamond come from two things that would multiply to be 12 and add to be negative 13. I got 12 because it's a times c. A is the number in front of x squared, which is an invisible 1. C is the last number, which is 12. A times c is 12. On the bottom of your diamond is your b value, the one in the middle, which is minus 13. You need to fill out the sides. You're looking for two numbers that multiply to be positive 12 and add to be negative 13. I'll give you a hint. If you're multiplying to be positive, but adding to be negative, that means you have two negative numbers. Right? Negative times a negative would be a positive, but a negative plus a negative would be a negative. Right? So what are two negative numbers that would multiply to be 12 and add to be negative 13? If you're stuck, you make a chart, right? Things that multiply to be 12. Negative 1, negative 12. Negative 2, negative 6. Negative 3, negative 4. One of these combos will add to be negative 13. In this case, negative 1 and negative 12. And those are the second terms of your binomials. We've successfully factored that now, or unmultiplied the trinomial, to become x minus 1 times x minus 12. Diamond method. Easy peasy. Okay, try D, E, and F on your own. We've got 3 trinomials that all need a factor. We know that trinomials factor to be 2 binomials. So I started off by just putting in my 2 blank binomials. Like this. Binomial, binomial. We also know that the first term comes from the first term there. Okay? The first terms create that first term of your trinomial. That's why it's always just A and A. Before it was X and X, right? So in this case, it would be A times A becomes A squared. It's the next terms that are trickier to get. To get the second terms, that's why diamond method exists. The top of your diamond. The top of your diamond is your A value times your C value. Your A value is this guy right here, an invisible 1. Your C value is 10. 10 times 1 is 10. The bottom of your diamond is your B value, which is your middle one, which is negative 11. You're looking for 2 numbers that multiply to be the top of the diamond, add to be the bottom of the diamond. 2 numbers that multiply to be 10, but add to be negative 11 would be negative 1 and negative 10. Right? Negative, negative is positive. Negative, negative adds to be negative. That means my sides are negative 1, negative 10. Those become the sides of my diamond, or the sides of my diamond. Oh, it's diamond method. In the middle one, we're going to do the same thing. They change the letter to by, so it doesn't do anything. It just changes that our first binomials, instead of being x and x, our first terms are going to be y and y. When you do your diamonds, I'm running out of space. The top of the diamond would be 4. The bottom of the diamond would be 3. Things that multiply would be 4, add to be 3. Whoa. Brain is stumped. 2 and 2, 1 and 2. No, that doesn't work. Anybody get one? Oh, good. Again, it's just as stuck as I am. So, when you get stuck, right, and you can't figure out what multiplies to be 4 and adds to be 3, we make our chart. And your chart is like your way of checking to see if there is a combination that works. Things that multiply to be positive 4. 2 and 2, 1 and 4. That's everything. That's the whole chart. Then you check if any of these work. 2 and 2 add to be 4, doesn't work. 1 and 4 add to be 5, doesn't work. That means this thing is not factorable. Now that rarely happens. Okay? It doesn't happen very often. So don't just go around to every question and be like, unfactorable, unfactorable, unfactorable. Right? You'll finish your assignment really fast probably. Try to get them all wrong. If you're ever stuck, make a chart to see what multiplies to be your A times C, or the top of your diamond. Then be certain that it's unfactorable. Don't just jump to the fact it's unfactorable. Does that make sense? F. So we set up F. We know we're going to get 2 binomials. We know the first term comes from the first term. Right? X squared comes from the first term. X times X. The sides of the diamond create the second terms of the binomial to create your diamond. You want 2 numbers that multiply to be 50, add to be 27. Or 2 numbers that multiply to be 50 and add to be 27.
25 and 2.
25 and 2 would be perfect, right? 25 times 2 is 50. 25 plus 2 is 27. Again, the order doesn't matter. So if you put 2 first, that's fine. That would be your factor trinomial. Awesome. Let's make it a little bit harder. Okay. We're going to build on this. We're going to look at this question which says factor the polynomial. Let's just pretend it doesn't even tell us this part. And that kind of spoils what's about to happen. So it's a factor of the polynomial. It's a test question. When I get to a factoring problem, I go to my decision tree over there, that thing we're building. The first step to every factoring problem is GCF. So if you look at this guy, you should ask yourself, is there any number that can divide into 4, 32, 48? And if there is a number, what's the biggest number that divides into all three of them? So for instance, 2 works, right? But is 2 the biggest one? No, what's the biggest one, Ken? 4, right? 4 goes into 4, 4 divides into 32, 4 divides into 48. Make sure you divide the biggest one out. It's been a while since we've done GCF, but you're always looking for the largest number that divides it. In this case, they all divide by 4. When you divide a GCF, it goes out front. 4 goes out front. And then you get a remainder. The remainder is what happens when you divide by 4. So 4x squared divided by 4 is just x squared. Negative 32 divided by 4 is negative 8. X. And 48 divided by 4 is 12. Before today, we would GCF and then be done. Now, we GCF and then we count how many things we have left over. We have 3 terms left over. 1, 2, 3. After I GCF, I count my terms, and I decide which way I want to go. I have 3 terms. I'm going to use diamond method. Right, but only on the part I've underlined here in orange or yellow, whatever color you want to call that. The 4 that's out front is still just going to be out front. It's a monomial, it's out front, it's by itself. But we're going to convert this thing into 2 binomials. We know when we factor a trinomial, it turns into 2 binomials. That 4 that's a monomial is still out front, just like that. To factor this orange part, I need to do diamond method. I draw my diamond. The top of the diamond is 12. The bottom is negative 8. 2 things that multiply to be 12, but add to be negative 8, would be negative 2 and negative 6. Right? 2 negatives multiply to be a positive, 2 negatives add to be a negative. So it would be negative 2, negative 6. And those can be hard, right? That's where that multiplication chart comes in handy. Awesome. Now to put this stuff actually into our binomials that I've drawn there in orange. We know the first term creates the first term, like that. And then we know the sides of the diamond become the second term in your binomial. That is now my factored polynomial. So I GCF'd, it's a monomial out front. I was left with 3 terms. I turned those 3 terms into 2 binomials. Now all I have is multiplication. Fantastic. Part B, we're going to try the same thing. You go to remove a GCF. In this case, there's a number and a letter that go into that GCF. What's the number I can divide up? 3, right? 3 can come out of all 3 of those. 3 goes into 3, 3 goes into 21, 3 goes into 30. What's the letter that can go into all those? X, right? Because there's an X in each one of them. So these can all divide by 3x. That's the GCF part of factoring. And I always try that as my first step. Sometimes I can't. All the examples above, I couldn't GCF. These examples, I can GCF. So I take that 3x out front. Then I have some sort of leftover. The leftover is going to be x squared. Then the leftover is going to be plus 7x. Then the leftover is going to be plus 10. You then count how many terms are in your leftover thing. In this case, there's 1, 2, 3. 3 things left over. I look at my tree. 3 terms means I use diamond. When I use diamond method, I know that I'm going to be left with 2 binomials. So I'm going to put those in here now. Binomial, binomial. I also know that the first terms of my binomial will create the first term for my trinomial. So x and x would become x squared. The sides of the binomial, the second term in each place, come from the sides of my diamond when I do my diamond method. The top is a times c, which is 10. This binomial has nothing to do with my diamond, right? I'm only looking at the stuff I have under orange. So 1 times 10 is 10. The b value is the middle one, which is 7. 2 things that multiply to be the top, that add to be the bottom, would be 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. Those things go into the second term. Plus 5, plus 2. That's my factored trinomial. That's about as hard as it'll get for today. Any questions about either of those? Awesome. Before we